Alright, hello and welcome to Exponential and Logarithmic Functions Day 4. We're going to talk about compound interest. So we kind of already touched on this idea of interest in the previous lesson when it comes to exponential growth. But I want to talk about a little bit more. This is, again, one of those real-world topics where the more you can understand this idea, I don't know, better off your life could potentially be with, investments and things like that and planning for your retirement and all that jazz. So, if this is something you're interested in, then I would encourage you to take some of the classes that we have here at school. We have like Intro to Business and and I teach a contemporary math class, that goes more in depth into these things. So I really encourage you guys, if you can find room for it in your schedule to get to contemporary math. So a bond. We're going to talk, just briefly introduce this idea of bonds. Okay, so a bond is a promise, right? People see their word as their bond and stuff like that, right? It is an investment. You hear about like stocks and bonds sometimes, okay? The promise is, it's you loaning money to a company and the company promising to pay that money back to you, or reward you, pay you back your money plus some interest and stuff like that for their gratitude for you loaning them your money and stuff like that. In kind of a basic sense, okay? The money you receive in addition to the original loan amount is called interest, right? And there's different ways you can get this. One way to get this is you get the interest at regular intervals. If that's happening, you have something called a conventional bond there. The intervals would be every 6 months you would get an interest payment, okay? Conventional bonds, okay, they pay simple interest. Now, simple interest, what makes it simple? It's interest earned on the principal alone. So whatever you initially loan to them in that bond, let's say it's like $1,000, then they will always pay you every 6 months the interest on that $1,000 you loaned them. On the other hand, another kind of bond is one that pays you all at once at the end. Okay, so you don't get any money in between. You have to wait from whatever time period you agree upon with the bond that you purchased or whatever. You have to wait till the end to receive your money back along with its interest. Okay, so conventional bonds, you get a little bit of money throughout, okay, and then your original loan amount back at the end. The zero coupon bond, you don't get any money in the meantime. You have to wait until the very end, or when the bond matures is what it's called, for you to get all of your money back and the interest that it grew to. Okay, so now. With zero coupon bonds, though, they pay compound interest. What is compound interest? It's interest that earns interest. So here in the simple interest, you only earn interest on the principal, right? So, and you'll see what that looks like in the table here. Whereas interest on interest, that means, you earn a little bit of interest, that gets added to your original amount, and then the new interest you get is from that new total. And so your money continues to grow, and it grows at a faster rate as it grows in this situation. Whereas this one, it will grow at a constant rate. Okay, so we'll show you that here in examples. So here's an example. Let's say you buy a conventional bond, so that's going to be simple interest, right? You get a little bit of money every 6 months or so. In this case, it's every year they're doing it. It's 5%. So you can see here that at year 0, at the very start, right, the value of the investment is $1,000. Okay, at year 1, okay, we have the value of the investment at the start as $1,000. The interest that you earn, though, is 5% for that year, so it's $50. Okay, but then the final value of your investment is still $1,000. That $50 goes straight to you. It doesn't get added on to the investment here. Okay, after year 2, same thing happens, right? You get paid $50, and your $1,000 is still being held by the company. 3 years later, you get another $50, and your $1,000 is still being held. And after the 4th year, you get one more $50, and you also get your $1,000 back. So the total is, you got $200 total in interest plus that $1,000 back that you lent them, for a total of $1,200. Okay, after 5 years. I'm sorry, after 4 years of investment. Okay, now. That's conventional, right? Now compare that to a zero coupon. Let's say you buy a zero coupon bond for $820.70, okay, and has a maturity value, a final value of $1,000. So they're saying, this is going to be worth $1,000 at the end, okay, and the maturity date, how long it takes to reach that amount, they're going to say is 4 years, and it's 5% annual interest, okay. The key here, right, is that the interest is reinvested, okay. So what does that mean? So for example here, again, year 0, we started with that $822.70 right there, right? And now year one, okay, it's starting with $820.70. We're going to multiply that $822.70 times 0.05, 5%, and that gives us the 41.14. That 41.14 interest, though, does not get paid to you. It gets added. Oops, this should be a 41.14. It gets added to your original amount that you lent to them, okay, $863.84 now. That's what you start year 2 with, and then it's that amount that gets multiplied by 0.05, so that new total. And so you see you get a little bit more interest. Your interest increases. And so then that gets added on to the start of the year amount, and so now you're up to 907.03. And then that's what you start with in year 3. Sorry, I keep hitting the wrong button. And that is what you multiply by 0.05, the new total there, to get a higher interest, 45.35, and that gets added on. And then the cycle repeats one more time. You multiply the new total there, you get $47.62 in interest. That gets added on, and then the final amount that you get back is $1,000. So with an initial investment of $820.70, you get return $1,000. Okay, at the end of 4 years. So you got to wait, right? You don't get any money in between, but you do get $1,000 at the end, guaranteed there. Okay, so, different considerations. So both same amount of time, both same interest, right? Interest rate, I should say 5%. Here, this simple one, though, you get paid this $50 every, every year for 4 years. Okay, but you also have to start with an initial investment of $1,000. Whereas this one, okay, you start with your $820.70, and you also get $1,000 at the end as well. Okay, but you don't get any of that nice little interest in the meantime. Okay, so different investments for different situations, different scenarios, okay? And these are things we can talk more about when we talk about contemporary math, but just so you can see the difference here, the power of, interest growing on interest versus just the simple interest kind of thing there too, okay? You might be an interesting exercise for you guys to try, and we can do that actually. We can actually see, what if we started with $1,000 in this scenario with the zero coupon, how much will we end up with? Will we end up with $1,200? Will we end up with more than $1,200? Will we end up with less than $1,200? We can talk about that later here, but I want to make sure you get through some of these other problems, okay? So, remember from the previous lesson that the general exponential growth function is this, right? Where you have your starting amount, 1 plus your interest rate, or your growth rate as a decimal. Okay, change the percent to a decimal, and then t is time in years, or time in whatever your growth rate is there, okay? For interest compounded annually, okay, which is reinvested, okay, this is our formula. You'll notice it's the same thing, right? Initial amount, right? There's the R's, okay, for the interest rate, and then t is time in, years in this case, because typically for interest it compounded annually, that means, we're going to talk about an annual interest rate there. So, example, how long does it take an initial investment of $3,500, so that's our P, that's where we start with, to grow to $10,000? So we don't know, when is this going to be $10,000 if we have an annual interest rate of 3%? So 1 plus 0.03, like that, okay, again, because 3% is equal, that's our R, and that's equal to 0.03 as a percent, as a decimal, I mean, and then to the T. Okay, so now we want to solve this. Okay, well, this is going to be hard for us to solve right now. We don't have a tool yet to help us get that variable. Sorry, I got crud on my screen. We don't have a tool yet to get that variable out of the exponent. Okay, so we're going to use instead as our graphing calculators for right now. All right, and then I'll show you guys how to do that eventually here. So, okay. So go to your y equals, clear it out, and we will go to our, excuse me, our equation here. Okay, so we want to know 3,500 is the initial investment, 1 plus 3% to the, and we'll use X here for our purposes. Oops, actually I gotta make sure okay, it's not going to do this for me, there you go. Close parentheses then to the X like that, there you go. At the same time, we'll also graph the 10,000, the other side of the equation there, and we'll graph. Okay, and of course we see nothing, right? Why is that? Well, if you think about here, what are we trying to graph? We are graphing 10,000 and 3,500. So these numbers are very large. We need to change our window here. Our Y max right now only goes up to 10. So we're going to go up to, let's see, like, let's go to 12,000, since 10,000 is the highest there. And now let's see if we can see. Okay, so there is our growth there. Okay, and I do not see it crossing yet. We need to go further to the right. So we'll adjust our window to the right. Let's try 100. Okay, there's the money growing. There's 10,000. Okay, so second, trace. Go down to intersect, hit enter. Go close to that point of intersection. I'm going the wrong direction here. I gotta go to the left. Okay, there we go. Enter, enter, enter. There's our point of intersection. So, how many years? What's the X value? 35.5 years, approximately. Later in this unit, we will figure out how to actually solve this using algebra, but for right now, this is the best we'll be able to do. Okay? All right, so let's try, let's look at one more formula here I've got for you guys. Okay? So what if we have interest that's compounded more than once per year? Okay, so we can adjust our formula here. What we're going to do, and this is the really crucial one right here. Okay, so because you can actually just remember this formula, you don't need to worry about the interest compounded annually, because this one will adjust, will fit that one too. Okay, so what this does, again, this interest compounding more than once per year, or the original interest compounding annually formula that we talked about here, these are all like that zero coupon bond, the second scenario here, where we're earning interest on the interest gets reinvested. Okay, but for this one, you'll notice that we're taking our interest rate and dividing it by n, because what happens when you have interest that's compounded more than once per year, that means you get a little like hit or growth of interest, you know, more than just once at the end of the year kind of thing. You get it like throughout the year at regular time intervals, okay? And that's what that n is. N is the number of times you get that interest per year. I keep hitting that stupid search button. So that's, you know, that's the important thing about that. But you'll see here that we still have that principal, right, our starting amount, the initial amount there. Oops, I think I was blocking the microphone. We still have that starting amount there. We still have our interest rate. But that interest rate gets divided by the number of times compounded. So let's say that you have a 5% interest rate, okay? If you get it, you know, twice a year, you don't get 5% twice a year. You get half of that 5%, so 2.5% at one half of the year, and you get the other half, the other 2.5% later in the year, okay? But it ends up working out better for you because that, you know, you grow interest on the original interest that you did and stuff, that you got and stuff. So it still is quote unquote 5%, but the growth is better for you. It works out better for you, okay? The more times it's compounded, okay? So you can see here we just throw in that n then times t. So again, if you're talking about like compounding twice per year, you're going to take your interest rate and divide it by 2, so that way it totals up to be the total interest rate. But then you're also going to take the number of years and multiply by that 2, because again, if you're, you know, doing a 10-year investment and it's compounding twice per year, that means really it's 20 times that you're getting that interest hit. So that's why you want to, you know, have that n times t there. So let's use the formula here. A person invests $1,200 in an account. So $1,200 is the starting amount. Okay, times 1 plus earns 2% annual interest, or R is 2, or 0.02. Okay, compounded quarterly. So quarterly would be how many times per year? Well, how many quarters are there in a year? There are 4. So our interest rate is going to be divided by 4. Okay, and then we will multiply 4 times the number of years, but we don't know the number of years because we want to know when does the investment reach $1,500. So that's going to be our final value here, but we're going to figure out what this t is, how many years it's going to take. And again, we'll have to go back to our graphing calculator. So let's do that here. Okay. So y equals clear. So now we're starting with $1,200, and we have 2% interest, quarterly compounded, so 1 plus 0.02 divided by 4, close parentheses, to the, I'm going to put parentheses around my exponent here too. I think it'd be a good idea. So it's going to be 4 is the n, and then x instead of t, because again, you don't want to use t's there, okay? So there it is typed in, and then we'll also do the 1,500. And we'll graph this. I'm not going to adjust my window here. I think it's going to be big enough that I won't need to. Yep, I can see that point of intersection perfectly. So second trace, go down to intersect, move your cursor down to that point of intersection, hit enter 3 times, and voila. After about 11.2 years, we'll say, and again, I'm using the squiggle equal sign because we're approximating. Okay, and so there it is. All right, I'll give you guys a few. Well, I didn't get to go over that last one here. Well, I'll cover that one here. You can stop here if you want to, and then get into the homework. I'm going to go ahead and just show you guys what would happen if we took this $1,000 and we did the 5% growth as not a simple interest, but a compound interest kind of problem. Okay, I'll just do that right over here. So I'm comparing it then. Let's say we put that $1,000 in a 0 coupon like we have right here. Okay, what's going to end up happening then is it's going to be the final value will be $1,000 times 1 plus 0.05. Again, we're just going to say it's compounded annually, and again, it'll be 4 years. Okay. So if I do that in the calculator, I'm just going to do it on my calculator that I've got by my hand here. You guys can type in that if you want to too. You get $1,215.51, we'll say. Notice that with the simple interest, so interest just earning on the principal, but not on the principal plus the interest, right? You get 1,200. But here with the compound interest, where you're earning interest on your interest, you get $1,215.51. Granted, the difference is $15, right? But still, it's 15 free bucks that you missed out on by taking this option. So things to consider, as part of investment, stuff like that. Anyway, good luck on the homework. And again, message me if you have any questions. Thanks, guys. Bye.